All right, so thanks so much, John, for inviting me to present this paper and for organizing this terrific conference. So I'm going to talk about issues of life expectancy, which I think are an important input into the types of issues Dan was just talking about on annuitization and working longer more generally. And I'm going to focus specifically on inequality in life expectancy, the association between income and life expectancy, which is a widely studied topic going back for many, many decades. And as you all know, it's well known that higher income is associated with longer life, but there are several aspects of that relationship that I think still remain unclear and remain debated in the literature. First, what exactly is the shape of the income life expectancy gradient? Is there a point after which the relationship between income and life expectancy becomes weaker, sort of a plateau beyond which money no longer matters? Is there a floor below which lower levels of income are no longer associated with shorter lives? Second, how are gaps in life expectancy changing over time? In an era of growing inequality, I think there's a lot of interest in understanding whether health inequality is also growing commensurately. Third, much of what we know about the relationship between income and life expectancy is at a national level, and there's a lot of research comparing relationships across countries, for example, in public health. But how does the relationship between income and life expectancy vary across local areas? Is there a lot of variation, as there is, for instance, in healthcare spending across different parts of the United States? And finally, and ultimately, I think the question we're interested in answering in this literature more broadly is what are the sources of the longevity gap? What drives the fact that high-income people live longer than low-income people? And ultimately, what might we be able to do about that from a policy perspective? So in this paper, we try to make progress on those four questions using de-identified data from tax and Social Security records covering the US population from 1999 to 2014 to provide a more precise characterization of income mortality gradients. The data set we're using, because it covers the American population over a 15-year period, has 1.4 billion observations on income and mortality, and so that allows you to do a much more granular analysis, as you'll see, of the relationship between income and mortality than was feasible in prior work that relied on smaller data sets. We characterize life expectancy by income over time and across areas, and that's going to allow us to do two things. First, we'll have more precise estimates at the national level than in prior work, where we'll document large and growing gaps in longevity across income groups. And second, and I think more importantly in terms of what we can learn from going forward, we'll document new local area estimates by income group. And what we show is that there's substantial variation in both the level and the change in life expectancy across areas, especially for low-income individuals. We also characterize correlates of the spatial variation that we document, but I want to stress that we're not going to be able to identify causal mechanisms in this paper. So we're going to be able to tell you the properties of places that seem to have relatively higher levels of life expectancy for the poor, but we won't be able to say precisely why that is from a causal perspective. The focus of this study is primarily, therefore, on constructing publicly available statistics to facilitate future work on understanding these mechanisms and to measure progress going forward systematically in terms of where we see increases in life expectancy and what we can learn from those changes. So looks like I actually have a different version of the slide deck than I had anticipated. So what I'm going to do here is skip most of the description of the data and methodology in the interest of time. That is covered in detail in the paper. I'll say a quick word on that and then jump straight to the results in three parts, showing you the national statistics, local area estimates, and then predictors of the local area variation. So just to quickly summarize what we do in terms of data and how we construct these life expectancy estimates. We have income data from 1990 to 2014 tax returns. We match that to mortality data from the Social Security death master file. These death counts are very closely aligned with counts you get from the CDC. And then we measure income using tax returns as household earnings. So think of this as basically adjusted gross income that you report on your tax return, Importantly, we see incomes also for people who don't file tax returns using information returns. So even if you don't file a tax return, we get your income from a W-2 form, for instance. We exclude people with zero income because we have trouble measuring the mortality rates of people who have zero income. And then finally, we focus on percentile ranks in the national income distribution. So rather than showing you the results in terms of how mortality and life expectancy relates to income measured in dollars, we rank individuals in the national income distribution within their birth cohort, gender, and tax year. So I'm going to show you everything by income percentile. And those percentiles are calculated by ranking people relative to everyone else born in the same year, of the same gender, and in a given tax year to account for economic fluctuations over time and cohort effects and so forth. Okay, so our goal is to estimate the expected age of death conditional on an individual's income at age 40, controlling for differences in race and ethnicity. And in everything that I'm going to show you, we're going to measure period life expectancy. That is life expectancy for a hypothetical individual who experiences mortality rates at each age that are observed in a given cross-section. So think of this as, in 2010, what were the mortality rates we saw at all ages, and what's the implied life expectancy for a hypothetical person who experienced those mortality rates? It's a standard way of summarizing mortality rates or estimating life expectancy in the literature. That would be very straightforward to compute. It would just be a mathematical calculation if you could observe mortality rates at all ages for all racial groups conditional on income at age 40. In practice, we face two missing data problems. First, because we only have a 15-year panel, we obviously can't see mortality rates after age 55 conditional on your income at age 40. Second, as you know from filling out your tax forms, you don't write down your race or ethnicity on your tax return, and so we don't see race and ethnicity in tax data. And so without going into the details of how we solved these two missing data problems, let me just briefly summarize the key concepts. So we are going to fill in mortality rates at older ages. We're going to first show that if you measure income at later ages up to age 62, there's basically a rank invariance property where people's rank in the income distribution looks extremely stable across ages between the ages of 40 and 60. So if you were at, say, the 75th percentile at age 40, you're roughly at the 75th percentile at age 50 and 60 as well. Not after age 62 because people start to retire. And so that allows us to use income at later ages in order to measure mortality out to age 76. And then to go beyond age 76, you need to be able to see mortality rates at older ages to get the full survival curve, right? And so there, we're going to rely on a well-known fact in demography, which is that mortality rates are very well approximated by Gompertz distributions. So that is the log of the mortality rate looks almost perfectly linear with respect to age. And remarkably, this turns out to be true even by income percentile. So if you take people at, say, the 5th percentile or the 90th percentile of the income distribution, you see that Gompertz property holds almost exactly. The log of mortality rates is almost perfectly linear in age. And so as a result, you can extrapolate out to what mortality rates would be at older ages with a great deal of confidence and thereby calculate life expectancy. To deal with the second problem of not seeing race and ethnicity, so this is just laying out the steps by which we do this. So I'm talking about step 3 here. We adjust for racial differences in mortality rates by bringing in data from the National Longitudinal Mortality Study, the NLMS, which gives us, for a smaller sample, information on race and mortality rates, so we can compute the differences in black-white or Hispanic-white mortality rates. And then we use census data on income distributions by race, by area. And we then put those data together with our data where we're able to measure aggregate mortality rates in each area for each income percentile to back out, if I know the black-white gap is 2% and I see the total mortality rate is 3% and I know the underlying fractions of blacks and whites, I can back out the underlying mortality rates for each race, right? So basically that kind of exercise combined with the Gompertz extrapolations allows us to get all the data we want on mortality rates at all ages by race and ethnicity. Okay, so I'm going to skip the rest of these details and turn to the results. So let's start by looking at the national statistics on income and life expectancy that we get from this procedure. So this chart shows you expected age at death versus household income percentile for men at age 40. So on the x-axis here is household income percentile. Just to give you a sense of dollar magnitudes, we're showing what these percentiles correspond to in the income distribution at age 40. So the mean income in the 20th percentile is $25,000, 47 at the 40th percentile, 74 at the 60th percentile, 115, and then in the top 1%, mean income is $2 million. So, this just reflects the fact that the income distribution in the US is very skewed. So going from the 20th to the 40th percentile is a much smaller jump in absolute terms than going from the 80th to the top 1%. So what you see here is that there's a very strong relationship between income and life expectancy. There's this monotonic increase in life expectancy with respect to income. And it looks almost linear in ranks. So it's linear as a function of percentile rank, which obviously means it's concave as a function of absolute income in terms of, in light of what I just said a minute ago. So the magnitudes here, there's quite a large gap. So if you take men in the top 1%, their life expectancy is 87.3 years in the US at age 40, compared with 72.7 years for men in the bottom 1%, so nearly a 15-year gap between the top and bottom 1%. Now, to give you a sense of magnitudes, how do we think about that 15-year gap? How large is it? I think one set of useful benchmarks is to compare these numbers to life expectancy across countries around the world. So this chart shows you mean life expectancies for all countries in the world from the World Health Organization. And we're showing with the red lines where life expectancies for men in the US at different percentiles fall in this distribution. And you can see that men in the bottom 1% have life expectancy that's between the average man in Pakistan and Sudan. Men in the top 1% have higher life expectancy than the average man in any country in the world. So there's an incredibly vast gap in the experiences of men in the United States depending upon their income. Now, if we look at women, you see a similar pattern of a strong association between income and life expectancy, but there's a smaller gap between the top and the bottom. It's about a 10-year gap instead of a 15-year gap. So another way to look at that is that the gender gap in life expectancy, we all know that women live longer than men, that it turns out to be quite differential across income levels. So the gender gap is much larger at the bottom of the income distribution, where women outlive men by about 6 years, than at the top of the income distribution, where the gap is only 1.6 years. And that, I think, is an interesting pattern that is consistent with a lot of recent work by David Otter and others, suggesting that women are more resilient in the face of hardship and poverty than men in a variety of different circumstances. Okay, so I've presented a static snapshot of what life expectancy looks like on average in the United States over the past 15 years. So what I'm going to turn to next is to ask how these gaps in life expectancy have been changing over time. And that naturally, in the context of this conference, is very useful, important in understanding the distributional consequences of policies like Social Security. If the life expectancy of the rich is increasing at a different rate than the life expectancy of the poor, then a policy like indexing Social Security is going to average life expectancy is going to have important distributional effects that we might be concerned about. So there's some debate in the prior work about exactly what's going on. I think the results we're going to present here are going to be consistent, for instance, with what Barry Bosworth is going to talk about in a later paper presented here using more recent data showing increasing gaps in life expectancy over time. So to show you what that data look like, this chart plots average life expectancy by income quartile from 2001 to 2014. So the blue series is for men in the bottom quartile, the orange series is for men in the top quartile, And in each dot represents a period estimate of life expectancy, right? So using the mortality rates in that particular year. And so you can see if you look at the series at the top first, men in the top income quartile, the annual change in life expectancy is 0.2 years, meaning that over this roughly 15-year period that we're examining, life expectancy for men in the top quartile has increased by about 3 years. In contrast, for men in the bottom quartile, life expectancy increased annually by only 0.08 years, translating to roughly a 1 year or so gain over the same period. So the gap in life expectancy is growing steadily between the poor and the rich over the 2000s. See a very similar pattern for women with significantly larger increases at the top of the income distribution than at the bottom of the income distribution. If you do this in a finer way and look by income ventile, so 5 percentile point bins, and plot that annual change, the slopes that we were looking at in the previous chart, you can see that for the very poorest men, the men in the bottom 5%, there was essentially no gain in life expectancy over the 2000s. In contrast, for rich men, there was a gain of roughly 0.2 years or so, 3 years over the past 15 years. So roughly speaking, the gap in life expectancy between the richest and poorest Americans has increased by about 3 years over the past 15 years, which is quite a substantial rate of growth in the gap in life expectancy, I think. Okay, so those are some results at the national level. What I want to turn to next is looking at these data at a finer geographic level, looking across local areas. So there's a long literature analyzing geographical differences in mortality that goes back to the work of Vic, who's here in the audience, and a number of others. What we are going to do, that's a little bit different from prior work, is disaggregate that geographical variation in mortality by income levels. And that actually turns out to be quite important. So prior work looked at average differences in life expectancy across states, for instance. Looking at the data by income level gives you a different picture and I think points in a slightly different direction. So to show you how this looks, this chart replicates the plot that I started out with on life expectancy versus income at the national level for people living in 4 large cities around the US: New York City, San Francisco, Dallas, and Detroit. And again, we're starting with men here. And what you see is a striking pattern that's representative of what we see more broadly, which is that at the top of the income distribution, there isn't much of a difference in life expectancy based on where you live. If you're rich, you live roughly the same amount on average regardless of where you live. However, at the bottom of the income distribution, there are really large differences in life expectancy across areas. Men at the bottom of the income distribution in Detroit live about 6 years shorter lives than men at the bottom of the income distribution in New York. Again, it's useful to have a benchmark to think about magnitudes. The CDC estimates that if we were to eliminate cancer as a cause of death, we would increase life expectancy by 3.2 years. So relative to that benchmark, the 6-year difference between Detroit and New York City at the bottom of the distribution is really quite enormous. Likewise, you see a very similar pattern for women with this fanning out, much more variance at the bottom than at the top. I think these patterns are especially striking if you look at San Francisco and New York City for women. The gradient is almost flat through much of the distribution, right? Low-income women in San Francisco and New York basically don't live that much shorter lives than people at the median or the 75th percentile, which is really remarkable given the 10-year or 15-year gradient that we're seeing in the US as a whole. So there's a remarkable amount of variation across places within America. So now let's generalize beyond those 4 specific cities and take a look at the US more broadly. So what we're doing here is classifying areas in the United States into 741 metro and rural areas called commuting zones, a concept of geography that's more increasingly used in economics, kind of corresponds to labor markets. And in each of those areas, we are calculating life expectancy for men in the bottom quartile of the national income distribution. And the way the map is colored is that areas that are in darker red have lower levels of life expectancy. The brighter colored areas have higher levels of life expectancy. So you can see some geographic patterns that some are familiar and some may be surprising. So for instance, notice that Nevada has much lower life expectancy for the poor than Utah. This is consistent with the contrast that Vic drew out in his work from many years ago. The West Coast and parts of the Northeast have much higher life expectancy than the rest of the country. One interesting pattern that might be somewhat surprising is that the lowest levels of life expectancy are kind of found in the center of the country, the Rust Belt area, so forth, not the deep South, which you might have thought, doesn't the South have the lowest levels of life expectancy, the worst health outcomes, which is what the prior literature generally suggests. So to understand what's going on here, it's critical to note that this map is being drawn conditional on having income in the bottom quartile of the distribution. If I were to show you the same map pooling all income groups, you get a very different picture, which is precisely that the Deep South has the lowest levels of life expectancy in the US, which is consistent with CDC data and prior studies. So what's the difference between these two maps? In this map, we're conditioning on the level of income, and in this map, we're pooling all income groups, right? So what's going on here is that levels of life expectancy on average are low in the South because the South has more low-income people, not because health conditional on income is particularly bad in the South, right? And so that, again, echoes the point that breaking up the data by income when looking at the spatial variation turns out to be quite important. You see very similar patterns for women. For women, actually, it's even more striking. If you look at women in the bottom quartile, the South actually looks like it's above the national average. And really the lowest levels of life expectancy are in this belt in the center of the country. Okay, so in the big map, it's hard to get a sense of the population centers of the US. So this list shows you the places with the highest levels of life expectancy and the lowest levels of life expectancy among the 100 largest CZs. So at the top, you get New York, a bunch of places in California, and so on. And then at the bottom, you get a bunch of cities in the Rust Belt, places like Gary, Indiana, Las Vegas, Indianapolis, Oklahoma City, and so forth. Then you get something like 4-year gaps, 4.5-year gaps between the very best cities and the very worst cities in terms of life expectancy for low-income men and women. Okay, so show one final set of results on changes in life expectancy, and then I'll wrap up by talking about what factors might drive these differences. So let's take a look at now trends by area. So again, starting with a couple of examples. So this chart replicates what I was showing at the national level in terms of life expectancy by year, but now for the set of people living in Birmingham, Alabama. And this is shown for men and women in the bottom quartile of the distribution. So notice here that the slopes are quite large, around 0.2 or 0.3. That is, we're seeing gains in life expectancy for low-income people in Birmingham, Alabama, that look comparable to the gains that we were seeing for the rich in the US as a whole. So in Birmingham, it doesn't look like the poor are really falling behind the rich. In fact, if anything, they're closing the gap relative to the rich. Gaps in life expectancy are shrinking over time in Birmingham. In contrast, if you look at Tampa, Florida, the poor are actually living shorter lives today than they were 15 years ago. So life expectancy is falling over time for low-income people in Tampa. So that, again, underscores the importance of looking at this geographic variation. We saw in the nation as a whole, life expectancy basically seemed constant for low-income people. There wasn't much progress. But that masks the fact that there are some places where low-income people are doing just as well as the rich, and there are other places where they're going in the opposite direction. Again, it's useful to look at which cities are at the top and which cities are at the bottom in terms of trends. So Toms River, New Jersey, which is New Jersey Shore, basically, Birmingham, Alabama, some of these other places like Syracuse and so forth have pretty substantial gains for low-income people over the 2000s. But at the other end, Tampa, Knoxville, Tennessee, Bakersfield, California, have substantial reductions in life expectancy over the 2000s. Okay, the last set of results I want to show is on correlates of this spatial variation. So what's driving these differences across areas? While I think ultimately we want to understand what the causal mechanisms are, as a first step in that direction, we're going to do a purely correlational analysis just asking, what are the characteristics of places where we're seeing high levels of life expectancy for the poor versus low levels of life expectancy. We're going to start by assessing measures of health behavior. So if you take statistics like from the BRFSS, like the fraction of smokers in the bottom quartile, obesity rates, exercise rates, we see that all of these measures, these proxies for health behavior, are very highly correlated with the differences in life expectancy across areas for low-income people. And this is pooling men and women. You get very similar correlations for both men and women. So for instance, if we take smoking, there's a correlation of minus 0.7. That correlation is so strong that you can just see it visually if you look at the map of smoking rates for low-income people in the US. So this is plotting the fraction of smokers by in the bottom quartile by area. Darker red colors are areas with higher levels of smoking. And notice that the map almost perfectly replicates the key features that I was pointing out before. Nevada has much higher rates of smoking than Utah. The highest rates of smoking are in this belt in the middle of the country, not in the deep south, and so forth. So that, we systematically find that if you look at these health behaviors, in fact, if you pool the three health behavior proxies, smoking, obesity, and exercise rates, you explain something like 90% or 85% of the variance in the map. So there's a really strong connection between these differences and in life expectancy and health behaviors. Now, you can then ask, okay, so it seems like health behaviors might have something to do with this. So stepping back, what then generates the variation in health behaviors and ultimately the variation in outcomes in terms of life expectancy that we're seeing? So the way we went about trying to examine this is to assess factors related to four widely discussed theories in the literature. Access to healthcare, naturally the idea that maybe access to better healthcare is what leads to higher life expectancy in some places. Second, environmental factors. So is it true that perhaps living next to a polluted area, as some of Janet's work suggests, for instance, is driving this variation across areas? Third, income inequality. So a very prominent literature in epidemiology argues that places with more income inequality tend to have lower life expectancy. For the poor, perhaps because they face greater stress or are lower down in the hierarchy, going back to the work of Marmot and others. And then finally, economic decline. So is it that places that are declining in terms of having fewer jobs, higher unemployment rates, does that kind of stress perhaps lead to lower life expectancy? So we evaluate each of these theories, again, just from a purely correlational perspective, so you should interpret this as suggestive evidence that could easily be contaminated by various confounds. But from a correlational perspective, if you look at various proxies for healthcare, like for instance, the fraction of people who have health insurance, or Medicare expenditures, or an index for the quality of care, a 30-day hospital mortality rate index, or an index for preventive care, like how many people get mammograms, or do diabetics get their eyes checked? You look at a variety of proxies like this, the four I'm showing you here, or a dozen other things that we look at in the paper, we never find really strong associations between any of these measures and the differences in life expectancy across areas that I was showing you. So health behaviors seem much, much more strongly correlated with the spatial differences than the differences in proxies for healthcare access. Environmental factors are hard to assess because there are lots of aspects of the environment that might matter. So we go about it in a slightly different way. We ask whether places that are more segregated by income, where low-income people might be living particularly close to polluted areas with factories, for example, and high-income people are living in different parts of the city where they're physically separated, that those types of cities have lower levels of life expectancy for the poor. And you don't find much of an association with segregation, suggesting that at least, from a correlational perspective, that spatial variation in life expectancy is not easily attributed to differences in environmental exposure. Inequality. So we correlate the differences in life expectancy with the Gini index, other measures of inequality that are not shown here, an index for social capital. Again, we don't find much of an association. So this is in contrast with the prior literature, where there's a large body of papers that shows that there's a strong negative association between levels of inequality and mean life expectancy. What explains the difference in our results? The key difference, we think, is that we are controlling for the person's own level of income. So remember that the relationship between income and life expectancy in levels is concave. So when you have more inequality, you're going to have a lower mean level of life expectancy because you gain less on the upside than you lose on the downside. Now, people have recognized this issue in the past, this mechanical connection between inequality and life expectancy, and attempted to control for income at the individual level. However, income measures in survey data are noisy, and so you can't perfectly control for an individual's income. When you control for income in the tax data, which is much better measured, the association between inequality and life expectancy for the poor essentially disappears. So we don't think that, in fact, that's a robust pattern that's true in practice. Finally, we look at labor market conditions, unemployment rates, changes in labor force participation rates, and so forth. And once again, we don't find much of a connection there. So finally, we came out, okay, so the four theories, we thought about investigating. Somewhat disappointingly, none of them really seem to be strongly predictive of the differences in life expectancy across areas. So the last thing we did is come at the data from a different angle and asked, so we've got all of these covariates that we've collected. What actually does explain the difference in life expectancy across areas? What is strongly correlated with these differences across places? And here are the top 5 correlates that we identified. In terms of the magnitude of the correlation, we find that places with more immigrants, higher house values, higher local government expenditures, higher population density, and a larger fraction of college graduates tend to be places with higher life expectancy for the poor. So think back to the examples of New York City and San Francisco that I gave you early on as places with high levels of life expectancy. They fit that description perfectly, right? They have a highly educated population. They're dense cities that are expensive with lots of immigrants. So what exactly is driving those correlations? We don't exactly know, but just from a descriptive standpoint, that seems to be a really robust pattern in the data. So to summarize, we find that low-income people in affluent, educated cities live longer and have healthier behaviors. I think a key question going forward is to understand why that's the case. Is it because there are perhaps spillovers from the rich to the poor? For instance, what types of cities enact smoking bans? Tends to be places like New York and San Francisco. Maybe that has an impact on the health of the poor. Or is it about direct peer effects? Or perhaps is it about sorting? The types of low-income people who live in New York and San Francisco are just different from the types of low-income people who live in Detroit or Oklahoma City. We think there's a lot to be learned there, and we hope people will study those issues going forward. So let me conclude by talking about some implications of this work. So we find that inequality in life expectancy is large and growing, but importantly, it's not immutable. There are some areas in the United States that have relatively small and shrinking gaps, and I think that is reason for optimism and reason for we can learn from those places to figure out how we might get improvements in life expectancy for the poor in other parts of the country. These differential trends imply that indexing eligibility for Social Security and Medicare to mean life expectancy will affect progressivity, will reduce progressivity, and so I think it's important to take this into account when thinking about those policies. I think in terms of tackling these disparities in life expectancy, it's likely that we're going to have to think at a local level. So for instance, targeted efforts to improve health among low-income individuals in places like Las Vegas or Oklahoma City. That's the way you want to think about the problem rather than at the national level, how do you improve the health of the poor? And I think thinking in particular about the drivers of health behavior is likely to be really critical. While we don't have all the answers on exactly how we should go about improving those health behaviors, we're hoping that the statistics that we've constructed in this study, which are publicly available on this website, healthinequality.org, will be a useful tool for all of you and many others to monitor local progress and ultimately identify solutions in improving the health of low-income individuals. That's all.